Let's now take a look at this review problem. Y triple prime plus 2y double prime minus 3y prime minus 10y equals 0, with these three initial conditions being given. Three initial conditions for a third-order differential equation. Okay, so to get started, we begin by writing the characteristic equation, r cubed plus 2r squared minus 3r minus 10 equals 0. That is a cubic equation, and so we have to somehow factor this. Well, we'll start by finding the possible rational roots. So the possible rational roots the numerator will be things that go into 10, so plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10, over things that go into the leading coefficient, which is 1. So I've got 8 candidates to test. So there's no guarantee that any of these 8 things are going to work, but if there's a rational root, it must be one of these 8 numbers. All right, start testing. 1, 1, 2, negative 3, negative 10. So let's see, 1, 1, 3, 3, 0, 0, negative 10 does not work. Okay, if at first you don't succeed, try again. So we try the next root. So 1, 2, 2 plus 2 makes 4, multiply, I get 8, 8 minus 3 is 5, 5 times 2 is 10, and that one works. So this factors as r minus 2, r squared plus 4r plus 5. So to get the roots, we use the quadratic formula. R is equal to negative 4 plus or minus square root of b squared is 16 minus 4ac is 20 divided by 2. So negative 4 plus or minus square root of negative 4 over 2. So negative 4 plus or minus 2i over 2. So negative 2 plus or minus I. So that's one root, or that's one pair of roots, and the other root, of course, is just r equals 2. And so that means that our solution is going to be y is c1 e to the 2t plus c2 e to the minus 2t times cosine of t plus c3 e to the minus 2t times sine of t. All right, I have a 0 on the right-hand side here, so I don't have any particular solution to worry about, and so that will be the form of the general solution. Now, the slight detail that I have to figure out is what are these three constants. So I've got these three initial conditions that I still have to worry about. Y of 0 is equal to 2, y prime of 0 is equal to 3, y double prime of 0 is equal to 4. So, no shortcut, we just have to figure out the first and second derivatives. Y prime of t is equal to 2c1 e to the 2t plus, okay, so derivative of the first will be minus 2c2 e to the minus 2t cosine t plus the first times the derivative of the second will be negative c2 e to the minus 2t sine t. Now again, I take the derivative here. Derivative of the first will be minus 2c3 e to the minus 2t sine t. Then plus the first times derivative of the second will be c3 e to the minus 2t cosine t. Okay, second derivative is going to be considerably messier. Second derivative of the first will be 4c1 e to the 2t. Okay, next we have, and let me put this all in parentheses just to make it a little bit more bearable. Second derivative of the first will be 4 e to the minus 2t times the second, plus 2 times the first derivative of the first times the first derivative of the second, plus the first times the second derivative of the second. Okay, then I've got the c3 thing to worry about, plus c3, second derivative of the first times the second, plus 2 times the first derivative of the first times the first derivative of the second, plus the first times the second derivative of the second. So those are my original function, first derivative, and second derivative. The initial condition is given at 0. So let's see what happens when I plug in 0 into all of these things. If I plug in 0 into the original function, we get C1. If I plug 0 here, I get 1 times 1, so plus C2. And then this part goes away. And this was supposed to be equal to 2. Y prime of 0 was supposed to be equal to 3. That's going to be equal to 2C1. Here, if I plug in 0 into this, I would get minus 2C2. Plug 0 into here, the sign of 0 is equal to 0, so I don't have to worry about it. On these terms, sign of 0 again is 0, so that goes away. Then I'd have plus C3 here, because e to the 0 is 1, and then cosine of 0 is 1. Okay, lastly, we have the second derivative. Plug in 0 into here, I get 4C1. Plug in 0 into this, I have a 4C2. I have a 4 here, and also I'm going to get a minus 1 here, so and a 0 here. So 4 times 1 times 1, here I'm going to get 2 times 0, and here I'm going to get 1 times negative 1. So the net effect is when I plug in 0 into this, I'm going to get 3. Lastly, plugging in 0 into this part, I'm going to get a 0 here, and also get a 0 here, because sine of 0 is 0. And then I'll get a minus 4 times 1 times 1. So minus 4C3. And that's supposed to be equal to 4. So the practical effect is that I now have a 3x3 system that I have to solve. So I'm going to do this one with augmented matrices, 1, 1, 0, 2. Then over here I have 2, negative 2, 1, 3. Then 4, 3, negative 4, 4. And so that is my augmented matrix that I'll need to solve. Okay, to get started on this, I'll get zeros in the first column except for the top row. So I have 1, 1, 0, 2. Okay, I'm going to multiply the top line by negative 2 and subtract. So that gives me a 0 here. Multiply by negative 2. Sorry, multiply by negative 2 and add. Multiply by negative 2 and add, I get 0. Multiply by negative 2 and add, I get negative 4. Multiply by negative 2 and add, I still get 1. Multiply by negative 2 gives me negative 4, plus 3 makes negative 1. Next, multiply by negative 4 and add. Multiply by negative 4 gives me negative 4 times plus 3 makes negative 1. Multiply by negative 4 and add, the negative 4 stays. Multiply by negative 4 gives me negative 8 plus 4 makes negative 4. Okay, now we're almost done. The next thing that I could do is multiply the second row by negative a fourth, but it's a whole lot easier to swap the first and second rows. Or sorry, swap the second and third rows. So 0, 1, 4, 4. I'm going to take the third row, switch it, and also while I'm switching, we'll multiply the bottom row by negative 1. Then the second row becomes the new third row. And then let's see, so top row stays the same. Second row stays the same. Third row, multiply by 4 and add. So multiply by 4 and add, I get 0, 0. Multiply by 4, this gives me 16, add for 17. Multiply by 4 gives me 16, add, I get 15. Okay, so looking at the equations here, I get 17 times c sub 3 equals 15. So that c sub 3 is equal to 15 over 17. Coming back up, I get c sub 2 plus 4c sub 3 is equal to 4. So that means c sub 2 plus 60 over 17 is equal to 4. 4 is equal to 68 over 17. And so c sub 2, or c sub 2 is equal to 8 over 17. Then lastly, looking at the top row, I have c sub 1 plus c sub 2 is equal to 2. So c sub 1 plus 8 over 17 is equal to 34 over 17. And so c sub 1 is equal to 26 over 17. So finally, I can now go back to my original equation. So with all that, let's come back to the differential equation, the solution I had here. So there's my y of t is equal to this. I just got done saying what C1, C2, and C3 are. And so my final answer will be that yt is equal to 26 over 17 e to the 2t plus 8 over 17 e to the minus 2t times cosine of t plus 15 over 17 e to the minus 2t times sine of t. And so there is the solution of this initial value problem. And the hard work for this one was taking the two derivatives and solving that 3 by 3 system necessary in order to solve this initial value problem.